Visual, thunder rolls. Fade in, a colossal engine mounted in a naval ship. Cut to a Kenworth T680 rolling through the mountains. Narrator deep, deliberate tone, one engine powers warships. The other, American freight. But what happens when you compare one of the world's most powerful diesel engines to the champion of US highways? Introducing, MTU 8000 series diesel engine versus the iconic Kenworth semi-truck. This isn't your average truck talk. We're diving into the extremes 9,000 plus horsepower against real-world road dominance. Direct hit. Stay with me, because by the end, you'll discover what the future of diesel power might look like and whether overkill could actually be the next frontier for freight. High voltage pattern interrupt, humor reset. Quick thought, if horsepower were dollars, the MTU 8000 could buy a mansion, while the Kenworth would get you a really nice garage. Act 1, Introducing the beasts, who they are and why they matter. Let's start with the heavy hitter. Wrench MTU 8000 a V20 marine diesel engine developed by Rolls-Royce Power Systems. Output, 9,100 horsepower. Displacement, 95 liters. Applications, naval vessels, ferries, high-speed defense ships. This engine is a floating fortress. Then, there's the Kenworth semi-truck, a symbol of American grit and logistics precision. Powered by Paycar or Cummins engines, these trucks max out at about 600 to 605 horsepower, with torque tailored for high-efficiency freight. Seems like an unfair comparison, right? But here's the twist: this isn't about which one's stronger. It's about how diesel technology is evolving, and what happens when innovation from one industry leaks into another. Act 2, Technical Showdown, Power, Purpose, and Performance. Brain. Let's talk power. The MTU 8000's strength lies in continuous high-load operation, often running for days at sea without fail. It features common rail injection, electronic engine management, and modular design for efficiency under extreme conditions. The Kenworth's advantage: smart integration. Aerodynamics, engine chassis synergy, and on-highway fuel optimization, all tailored for long-haul profitability. Checkered flag pattern interrupt, engage again. Imagine pulling into a truck stop next to someone idling a 95-liter V20, talk about intimidation. But good luck finding parking. Hammer and wrench maintenance and practicality. MTU engines are maintained in shipyards with specialized teams. They're over-engineered, built to withstand saltwater, combat environments, and round-the-clock operation. Kenworth trucks, however, are designed for rapid diagnostics, fleet-level repairs, and economical uptime. In trucking, downtime is profit loss, and Kenworth minimizes it with onboard diagnostics and telematics. Fuel pump fuel and efficiency. The MTU 8000 consumes hundreds of gallons per hour, while a Kenworth averages 6.5 to 8.5 mpg depending on load and terrain. So while the MTU dwarfs it in size and strength, it's not built for roads, regulation, or return on fuel spend. It's engineered for raw, sustained maritime dominance. But, here's where it gets interesting. Act 3, The Future, where these worlds collide. Lightbulb diesel technology is converging. Marine-grade systems like advanced fuel injection, predictive controls, and hybrid electric coupling, all pioneered in engines like the MTU 8000, are beginning to influence truck engine design. Manufacturers like Kenworth and Paycar are borrowing concepts like thermal efficiency mapping, load adaptive fueling, and even engine quieting tech used in naval stealth craft. So while we won't see a full-blown MTU engine in a Kenworth anytime soon, the DNA is beginning to merge. Crystal ball, and here's the kicker. Rolls-Royce is now developing hydrogen and methanol-capable versions of its large engines, and Kenworth is already prototyping hydrogen fuel cell trucks and battery-electric long haulers. We're witnessing the beginning of cross-industry diesel evolution, where the power of a warship and the precision of a freight truck may meet in a zero-emission future. Hourglass not done cliffhanger, end with urgency. So the question isn't whether the MTU 8000 can beat a Kenworth. The real question is, when trucks stop running on diesel, whose tech will drive them? Naval-grade innovation, or precision-engineered logistics machines? Because the next truck you spec might owe its brain and brawn to an engine built for war. Clapperboard outro, call to action plus next video hook. Speech balloon. Drop your thoughts below. Could mega engines like the MTU 8000 shape the next generation of land transport? White heavy checkmark. Subscribe if you're serious about understanding how diesel tech is evolving across industries, because in our next video, we're going deep into Kenworth's zero-emission roadmap: hydrogen, electric, and hybrid. This isn't just trucking. This is the future of power. End screen, subscribe button, recommended videos, channel logo with engine sound. Fade out.